Hello, everyone. Hopefully you're back from snack break now. And we're going to get into the hands-on coding portion of this tutorial. So to start off, this is a link here to a hosted version of what the final app will look like that we're going to walk you through the process of building. So you can feel free to pull that up. I'm going to walk you through it in just a second. There's also a shortened, sorry, I realize that blue is not super visible there, but it's a shortened link to view the slides. The slides are going to have the code for each step. Basically, for each step of the tutorial, we're going to describe to you what you'll be implementing and give you some hints on how to implement it. But at each step, we'll also have, if you get stuck, you want to take a look at what the code should look like for that step. There's code in the slides. On each slide, there's also a shortened link to the GitHub repo, which has a Python file for each step of the way as well. So that QR code will take you to these slides, which I'd recommend also having open. So let me open this. Oh, wrong link. Hold on. One sec. So this is the demo app that we're going to be building, and there's two parts to the app. The first part is an analytics dashboard, and this part of the app examines statistics that are taken from the Streamlit GitHub repo. So basically looking at statistics related to how the code has changed over time, who are the folks who have contributed to the repo over time. You can also feel free to, if you have a repo that you want to examine other than the Streamlit repo, or even if you have other data that you want to build an analytics dashboard for, you're welcome to use that as well. You don't have to follow this example exactly, but this is what the demo app looks like. You can see we have a slider here to allow you to specify the date range for these charts here. You can see this chart is displaying weekly code changes, cumulative code changes. You can also see the raw data that we're visualizing here. We've got these nice tabs. This tab is focused on commit activity. And again, you can also look at the raw data there using ST metrics right here to surface some statistics. And finally, we have a contributors tab. Again, you can use these different input widgets to filter the data that's being visualized. You can look at a specific, this is Adrian, our CEO, or former CEO and founder of Streamlit, and you can look at how much code he has contributed. So that is the first part of the demo app. The second part is creating a chatbot using Streamlit and creating a RAG pipeline using Llama Index. If you're not familiar with RAG, that stands for Retrieval Augmented Generation. And the idea here behind this part of the app is to take a set of markdown files that we're going to use as basically a knowledge base for a large language model, so that when you ask questions of your chatbot in this part of the app, the responses that you're going to see are generated by using a combination of, in this case, GPT 3.5, but also those markdown files. So in this case, it's really handy to be able to augment the large language model with the files, because the markdown files from our docs reflect features that are more recent than the data that GPT 3.5 was trained on. So for example, experimental fragment was released relatively recently. So if you went into ChatGPT and you said, what is Streamlit's experimental fragment feature? It would say, I don't know. So you're also, in this case, welcome to use other markdown files or other files if you want to create a chatbot that is more specific to your own use case. But we're going to walk you through this example. So those are the two parts of the demo app. Let me pull up And Tony is going to start walking you through the first part. Let me exit out of here. Okay, this doesn't want to let me. Tony, you're going to have to exit again. I can't exit out of this window.
Right, let's do it.
It's harder than it looks, I swear.
Yeah.
You're going to have, there's a lot of slides.
Yeah. All right, cool. So this is what we'll be building, and Caroline already showed you how that looks like on the code side, on the app side at least. So the first thing we want to do here is, let me just navigate here. Yep. So if you already have your laptop fired up, you can, whatever IDE you like using, it could be VS Code, or whatever really you want to use in this case. The first thing you want to do is install the packages if you haven't already. And these are the packages that you would want to install. And the quickest way to do this is open a folder within your directory structure. Just create a requirements.txt file, and then add this packages here to that requirements.txt file. So you can add this in here, and then save that. And then once you've done that, you just run this on your terminal, which is pip install requirements.txt, and it will install all this requirements in your system. And I think if you want to go even a step further, if you know how virtual environments work, you can create a virtual environment and then install this within that to isolate your application. And this should take about 5 minutes. So if you need any help, just raise your hand up, and we'll come around and help you out with that.
Yeah, we'll be circulating around if anyone gets stuck.
Yeah. Also, if everybody's done this, and maybe this is too easy, just let us know as well. We can just proceed instead of getting stuck here.
Yeah, show of hands who's still working on it. Anybody? Okay,
Cool.
we'll wait over.
All right, we'll take about 2 minutes to finish that portion, and then we'll, unless everybody's done. All right. We'll just take about 2 more minutes, and then we'll move to the next section. All right, cool. So while everybody's still working through that portion, I can go ahead and talk about step 1 of building this app. So the first step you want to do, once you've installed your dependencies, they're good to go. The first thing you want to do is create a Python file, and you can name it however you want. We love emojis, so that's why we have emojis everywhere. So we named it 01, and this is the main file that kind of you call it when you run the app. So we named it as 01 underscore. We put a graph chart emoji there, and repository underscore analytics.py. And this will show up in the original app. It's going to look, let me just go back and see if we can find that. So if you look at this is how it's going to look like. If you name it that way, it's going to look like this. I know it's not big enough, but like it's going to look something like that in terms of naming on the file. So that's why we named it that way. But you can do without that. You don't need to have that in there. And then the next step within that file itself that you've created, you need to import the libraries that you're going to use for this app. And we'll need Streamlit, of course. So you do import Streamlit as Streamlit, and import pandas. And we'll also use Plotly. So you import plotly.express as px. Cool. So once you're done with that step, the next step is loading in the data. So there's 3 CSV files in the repo that we shared. And if you don't have the link to the repo, just enter this bit.ly link st_vis data. So we have 3 CSV files in there, and one of them is for contributors data. Another one is for commit activity, and I believe the other one is for commit activity as well. So those are the files that you will need. And so once you've downloaded those files, you save them in the folder in your root directory. You can name it whatever you want to name it, but in this case, we named it as data. So maybe for consistency, just name it data, and then put all those CSV files in that data folder. And once you're done with that piece, we're now ready to create our functions within our first function within the application. So the first function will be a function to load these CSV files that we've saved. from those paths, and then load them in and just return a data frame on the other side. So you would use pandas read CSV function to read in these files, and so you can create like a generic loading function. So you don't need to have like specific, just generic one, file path as the parameter. And so all you have to do with this function, you get the path to your data. So it would be data / whatever name of the file. And then if you load it into that function should take that file, load it up as a PDF, and then just return that PDF. And if you're feeling ambitious, you can add error checking in there as well, just in case the file is empty or there's something going on with it. You can add that to check so that it returns a good error to the user or yourself as well. So also remember, use ST cache data, which we learned about earlier, because we don't want to be loading this data all the time. So we want to save it as we want to cache it, and so it makes it much easier. So you can decorate that function with the ST cache data. So this should take about 15 minutes to go through all this steps. So we'll be walking around. If you have any issues with it, just raise your hand up. We'll come to you and help you out. And if you're also feeling really stuck, there's those slides we share. Just go to the next page.
Yeah, so after each of these steps in the slide deck, we have a warning slide. So if you don't want spoilers, you should skip the next slide. But then we have the code. We also have a shortened link to that file in the GitHub repo. So if you're really stuck and you want to copy paste, or you want to just like kind of look at it and try to reproduce it, that is also an option. One other thing, when you import Streamlit, you're going to want to do import Streamlit as st, so that you can use the st.write, for example, syntax that's in our documentation.
All right, one more thing, and somebody brought it up. We're good point. So if you're the best way to kind of like build these apps, mostly Streamlit apps, you need to pull up your VS Code or whatever editor you're using side by side, like a split screen with the localhost web already, localhost for your file. And that way, when you implement the changes, you can see it reloading directly on the app. So just a point. If you're already doing that, then good. If you didn't know about that, then that's probably a good tip. Oh yeah, I can do it here to demo. Probably turn on the mic. But anyway, yeah, so this is the code. Splitting the screen that way, it helps you with your developer workflow. Makes it much easier instead of navigating all over the place. So you implement the code, and you see it showing up on the other side. Cool. So hopefully at this point, you've written some of this code. So I'm going to walk through a bit of what's on the screen here and explain a little bit. So in this case, you did create the function, the load data function. And here we're just passing in the file path, which you've already saved those data in the data folder. So for here, we'll just pass in a file path, which is going to be a string, and it should return a data frame at the end. And we're also decorating it with the st cache data decorator to cache the data. And the first step here, I just used a try except block here. And this is really to help with error handling. And we're creating here a variable for data, and then we're using that to read the CSV. And we're passing the file path from our function up here. And if the data would then return from this data frame is empty, if there's no data in that PDF, not PDF, but in that CSV. And this is really because sometimes you don't want your app to fail, and then the user's like, wait, what happened? Like, I don't know what's happening. This is basically what we're doing with that. So if it's empty, we're using here the st.error, and this, instead of like printing out the statements in your file, like how you do like stprint, or if you're using logging, which is probably the best way. But here we're using st_error, and it's going to show this to the user. There's no data found in the CSV file. And of course, like, as I said, we like emojis. It's going to have an icon in front of this text here that says, hey, no data found in CSV. And if there's data, it will just return the data frame itself. Another exception that I added there was if there's no file found error. So if there's no file within this file path, it's just going to, again, use st_error, and it's going to say, file not found within the file path that you passed in, and it's just asking you, please check the file path, and also the icon. And another error that we're checking here is using pandas errors, and if there's a empty data error, so no data found in the CSV as well, in this case. And we also have an exception, and this kind of catches anything that we missed up here, and it's just going to return that error with a detailed message there. And this return empty data frame is just going to return empty data frame if any errors occur within this step, so that way your app just doesn't crash. And this is good practice so that your users that are using your app are not guessing, what's happening in this app. So it's good to give them so you can add even more stuff here, that all the edge cases of what could happen when you're loading a CSV file and what are the potential things that could happen to it. You can add all of it here as well. Cool. So hopefully yours look like this. And also just a note, at this step, if you're running this app, you did Streamlit run that app, you should see nothing on the screen because we haven't really called anything out. We haven't said, hey, show these on the app. So nothing should print on your screen. So don't be alarmed. All right, so the next step, which is step 2 now, is we need to set up the main structure of the app. And we'll use the stpage config. And the stpage config really helps us set the app itself. And we're able to see the different things we can set. For example, let me just show the app. That might make more sense. So this is the app, and maybe I should. All right, so if you can see in the app, we have here, let's just go up here to analytics. In this app, you can see up here, there's like a emoji, like an icon for the app, right? So if you use set page, you can have that set up there as well. And we're also setting the title of the app on this next section. So you need to set that up. And also we'll set up the tabs within this page of the repository analytics. So that way you'll be able to add the content that what we need to pass in each of this section. So let's go back to the slides. All right, go in the wrong direction. All right, so for the page config, you can look up the code as well, or in our docs as well, if you want to find out and see all the options that you can actually add onto it instead of just using the one we've provided. You can add more stuff to it as well. And setting up the title for the app. And then the next thing you should do is set those 3 tabs that we will be using to show our data analysis. So the first one should be the code frequency tab, and then the commit activity tab, and then finally the contributors tab. And you can add emojis in front of these tabs if you want to, or if you don't want, you can just keep it the way it is. This should take about 5 to 10 minutes. We'll also be walking around if you need any help. And for this time, once you get to this code, once you've implemented this step 2, something should show up on the screen this time. So don't be, something should show up this time, so you'll be fine. Right, so this is how your code should look like. So you'll create a main function, and we're creating this because down the road at the end, we'll have a if name main block, which is a Python way of making sure that the code or the scripts get intentionally run as an application. So once you've created that main function, you use the setPage to set the page layout. And so here we're passing in a layout. We want it to be wide because our charts are going to be on the entire app. You can also set it to centered, which it will bring your app to the middle, more squished in. And then we're setting the page icon as this emoji right here. And these are these other parameters that are part of this stpage config that you can add if you want to go to our docs. You also see and kind of make it, however you want. And we're also creating here the title. And it's a GitHub repository analytics dashboard. And I set here the anchor is full. So what this means with the anchor, if you hover over the titles or subheaders or headers, you will usually see like a link. It's like a like an anchor link. So basically that kind of tells you where on the page you are, and you can copy the URL for that as well. So you can go directly to that page. But in this case, we're setting it to false. And we're creating also the tabs, the 3 tabs for code analysis. The first one is the code frequency, commit activity, and the contributors. And initially here, what you need to do, we're writing it as tab 1, tab 2, tab 3. You can actually name it whatever you want to name it. You can say code frequency, whatever you want to name it. And then we're using the SD tabs here, which you're passing in a list of the tabs that we want to have in our application. And when you run this app now, if you have the if main app at the bottom, if name equals to main, and then running the app, if you run it with that, it should have, you should see something on the screen popping up on your app. At least you'll see the tabs, you'll see the header, the title on that. Cool. Now let's move to step 3. So what we will do here, we'll load code frequency, CSV, as our first tab, and build the first tab of the code here. So we'll convert, the first thing we want to do once we've already loaded that data, you want to convert the week column to pandas datetime, because it's in a different datetime. I think it's Unix, so you need to convert that to pandas datetime. And the hint for this, you can check out pandas docs for datetime conversion, and you can go to bit.ly.pandas datetime, and you'll see how they implement that change of time right there, and you can implement that in your code. And then the last thing here, you want to display the data within an expander. So using ST-expander, you can have data within XT-expander, so you can preview what that data looks like within ST-expander. So you can use something like ST-data-frame within that ST-expander. Cool, so that's the next step if you want to play around with implementing that, and then we'll go over the code once again. So if you're stuck, of course, raise your hand, we'll come around, or you can jump to the next slide. All right, so let's go over the code for this step. So for tab 1, and this is part 1 of the code for tab 1, you should have the ST with the tab 1. So we're using the tabs that we created earlier, and you say you're using this with notation with tab 1. So everything that you're going to write under with tab 1 are going to show up on the first tab of your code. And so we're writing the subheader for this, and we're just using ST subheader, GitHub code change visualization. So that way, if a user comes to that tab, they know, okay, what's in here is about GitHub code change visualization. And I have this also SD info, which is another element that kind of just adds extra information. It's going to show up like a caption. You can add it like a blue frame, which is more information. And you can also add an icon to it, and it just says visualize code changes over time. And then we're loading and pre-processing the code frequency CSV data that we have already. So here we already created the function load data earlier. So what we'll do is we'll get that load data function, and we'll pass in the file path as a string, which we already talked about, which in this case, the file is within data, and it's called Streamlit code frequency stats.csv. And the first step is we want to convert the week column to datetime, and we use pandas to datetime function here, and we'll convert that week column to datetime, so that way it renders pretty well on our app. And then the last step here was just show the data or the raw data in an ST-expander. So if somebody clicks on that expander, they can see the data, and they can also collapse it to close it so they don't see the data all the time. And so we're using ST-data-frame, and we're just directly passing that code frequency data, and it's going to pop up on the app. So this is how your code should look like at this step. And I think a lot of you probably struggle at this point because you're like, yeah, you're supposed to show up on the screen, right? But it's not showing up. So there's a good reason for that, because now you have two functions, and let me show you how to do that. Let me just go back. So in your app, at the bottom of the two functions that we've already created, you just need to add this section right here. You just need to add this. If name equals to __ main, this main code block, just add this at the end of your two functions that we've created, the tab one, the main and the data loader. Just add this at the bottom and save. And now it should pop up on your local host. You'll see the app already with the code that you've already added in. And if you don't add this, the reason is because we only have two functions, and we're not really telling the script to do anything, which is like, yeah, you got two functions, but you know, what am I supposed to do it? So he's going to show you a blank screen. If you add this, then it will pop up on the screen. Hopefully that helps most of you. You're stuck with that. Cool. All right, for step 4, we want to still within tab 1, we want to implement the code frequency tab now. And let's see. So for this portion, what we want to do is implement a date range slider. And we did talk about some of this as well. And this is to help with selecting the period of interest. So the data is spanning since like 2018 when the first commit for Streamlit was made to May 5th of 2024. So that's a lot of data. So maybe you want to like see only a window of data or window of time of commits or frequency, code frequency. So this slider will help us choose the range, and you can scroll the slider from both sides to narrow down the range. And a hint here on how to implement this, you will need to find the minimum and maximum periods of the data set, so 2018, 2024. And you can do that using the pandas min function and also the max function. So within using your data, the code frequency data, just you can find out how to do that, and we'll walk around as well to help you with that. And then after you have the minimum and maximum dates, you can use Streamlit slider function and pass those in to allow selecting a date range for what you want to do. And then you can also add a filter, a data filter, based on this selected date range. So you have a data filter within it as well. That way, when somebody selects a specific date range, it filters the data based on those specific 2 dates and shows you the data for just that window of time. So I'll give you a few minutes here to implement that, and then we'll show you how that looks like in code. And we'll walk around as well to help in this section. All right, so we know time is going real fast, so we're just going to try to get through as much of this as possible. The good thing is you have the slides, but so we're just going to go over to the code for this section. So I'm just going to walk through the code for this part that you're working on. So we have implementing the date range slider. So the first thing we want to do is get the minimum week and the maximum week. And here we're just using pandas functions really to do this. And we're taking that code frequency data, and we're using the week column because that has the dates. And then we're just passing in using the minimum to get the minimum dates of the entire column of weeks. And then also we're using the max weeks here. We're using max to do the same thing for the max dates. And we're getting those two, which is the max and the minimum and max. And then we're creating a slider here. And we have 2 output that it should return, which would be the start week and the end week as the variables there. And we're creating the slider. We're directing the user, hey, select the date range once they see that slider. And we're passing in the minimum value as the minimum week, which is that right there. And then the maximum week. And the value as well is the minimum week and the maximum week as a enclosing range. And then the format of the date that you should show on the slider is month, date, and then the year. And then the next step here, we are filtering data based on the selected date range. So based on the date range, we want to filter the data to get on the data for that date range that the user selects. So in this case, we're also using pandas, as you can guess. So we have the code frequency, week. We're getting the column of week, and we're saying here if the dates within this week is greater or equal to the start week. We're not really saying if, but we're just saying the code frequency week greater than or equal to start week. And also the code frequency is less than the end week. Get that data and put it in this filtered data variable. Cool. Now that we have this piece done, we can move to the next section. And in this next part, we'll just need to write a subheader. And the title for the subheader should be Weekly Code Changes Comparison. We're just comparing weekly changes that's happened with the code that's been added to the repo. And display weekly code changes comparison using the area chart. So here we want to use the SD area chart to display this data. And I mean, you can feel free to add or play around with different charts to see how they look like when you add them on there. This is just the one we picked for this one. And then create a subheader, another one, for the section displaying the cumulative code changes over time. And under that, you will display the cumulative code changes stats using a scatter chart. So we're using 2 different charts here. So we have the area chart and scatter chart. And you can play around with different charts here to see how they would look like, to find the one that you like as well. So we're definitely not going to take 15 minutes because that would run over the time. So maybe I'll give you all a moment to look at it, or
More than a moment.
yeah, more than a moment, a little bit. And then we'll just jump in and continue to the next steps. All right, so we're going to move over to the next slide. And if you feel like you're still behind, you can always find those code and copy it. So I'm going to walk you through the code for this section as well. So we were supposed to make a subheader, which is using st subheader. And we're just passing in there saying, hey, weekly code changes comparison. And this is just an extra piece of column that we're adding here as positive deletions, just because the data that comes in usually has negatives or deletions from the repo. And so we just make that positive if we need to, although on the chart it won't show up as it will show up as a negative. The next step here, we're just displaying the area chart for the additions and deletions. And we're using st area chart, and we're using the filtered data, and we're setting the index to be the week. And we're passing in the additions and deletions columns as well there. And just to make it colorful, right, make it look nice, we are adding the hexadecimal colors here for green for additions to the repo and the red one for deletions from the repo. That way it looks color-coded and looks kind of cool. And then we have the next section here, which is the display cumulative code changes over time. And we're also using the subheader here to just guide the user on the app, hey, this is the cumulative code changes section. And we are filtering again the column of cumulative additions, and we are filtering that and using the function from pandas as well over there for the cumulative sum. And for cumulative deletions as well, we're summing them up as well. And then we're using st scatter chart in this case, and we're using that filter data. We're setting the index to be the week, and then passing in the cumulative additions and the cumulative deletions. So if you save this and run your app, you should see some changes. You should see some charts on your app at the moment. If you're not seeing any charts, let us know. Cool. So let's go on to the next stage, which is step 6. We have the implement commit activity tab. So this is a new tab, the next tab now. And so you can do with tab 2 in this case, because we finished with tab 1. So we go with tab 2, and then you start again. We will need to load the commit activity CSV data using pandas again, just like we did on the first tab. We're doing almost the exact same thing on the tab 2, but this time we're just loading a different file name. And then we need to process that data again by converting the week column to date using pandas. And you probably already did this on the first one again, so it's probably going to be something similar. And then we need to display the raw data in a Streamlit expander, just like we did on the first one. So these should be a little more quicker since you've kind of got the reps in a little bit. But I'll give you maybe a minute or two to get that through, and then we'll go through the code. All right, so while you're walking through that, notice that we still have like 5 minutes left or less. So what I'm going to do, I'm just going to run through all the remainder of the code for at least the visualization app itself, and that way you can understand how you can implement it afterwards. And so let's do that. So with tab 2, again, what we're doing here, again, subheader, info as well, extra information for the tab 2. And then we have the commit activity data. Again, here we're using the load data function, so making it more modular so that we don't have to do things over and over. So load data again, but this time we're loading a different CSV, which is the commit activity stats. And here again, we're using, like we did earlier, we're just also converting that week column to daytime. And again, we're displaying that data, the raw data, using this SD data frame under the expander. So people can actually interact and see what the raw data looks like, and then what are we going to do with it after that. All right, so step 7, what I've had you do is display the metrics for the commit activity using SD metric. And the hint for this was you would have needed to create 3 columns. So, and based on the stats that you need to display, and the 3 stats would be the total commits, average commits, and weekly changes. So you would need 3 columns for each one of them. And then finally visualize the commit activity using a bar chart. And I urge you to experiment with different charts to see what looks best for you. All right, and let's see the code for that. The code for that would look like this, you know. So you have the total commits, which would be summing up all the total column of our data. And then we have the average commits, and all this is using really pandas, which is really cool. And then commit activity, and then the total again, we're getting the mean of the total activity, and then we're getting the weekly change, and we're using the percentage change, and using this ilog here to get the weekly change. And then we're instantiating the columns. So for columns, just like we did with st tabs, we just do the same thing here. We have column 1, column 2, column 3. And then here we're just saying st.columns and then 3. 3 just meaning we have these 3 columns that we need to create. And then here, instead of using the with column 1, like how we did with st tab, in this case, I'm just passing directly, which is another way you can do it as well. So column 1 dot metric. So you can see here, column 1, we're just replacing the, typically we would have st dot metric, but since we've already kind of instantiated that up here, we just pass in column 1 because we want this to go to column 1 and metric. And then this is what the label is going to look like, which is the total commits. And then that's the integer that we want to show on that column, on that metric, which is the total commits. And then the second section, the next metric would be average weekly commits, which we've already, all of it, have it up here ready. We're passing that in with a 2 point there. And then column 3, we're using the weekly over, week over week change here. And then finally, we're using st bar chart, and we're displaying the data here with week and total. Cool. Now, the next implementation I would have had y'all do, which is for at least for tab 3, would be add a subheader first, which is the contributor analysis. And this is really cool because then you get to see who you can parse through and see who actually did what, how many did they commit within different time frame. So again, here we would load and pre-process the data just like we did with the other 2. And the hint here would be to rename columns as needed. So this data has some abbreviation. I think you had like W, deletion, and things like that. That it doesn't make sense for a normal person. So if you add, like, make it more readable, people can understand what these columns mean. And then you also need to convert the date column to date time. And then also drop some of the columns that we didn't really need. And all this you can use pandas. And I did annotate here the columns that we will not need for this visualization. So author, node ID, and all these other ones. And then finally display the data set in SD expander. And let's see the code for that. The code for that looks like this. So again, subheader and info as well, just like we did. And then we load the data, again using the load function, but this time passing in the contributor data stats, CSV. And then the contributor data, we want to rename them, and this is what I was mentioning. Some of the columns had A, D, C, and W. So for somebody who might not even know what that means, so A was for additions, D for deletions, C for commits, and W for date. And we want to keep that in place. And then here we're just doing we're converting the date column to datetime using pandas. And then we're dropping the ones we don't need here, and we're instantiating the columns that we don't need. And then we're using contributor drop method here from pandas as well. And then we're showing the data here on the SD expander. Oh, 1 minute. I'm going to need to speed through this. All right, let me just show the code, right, for the next part. Maybe much easier. So step 9, I would have had you just calculate the total activity for each contributor. You would have the contributions there. And then the group by author, we would group the data that we've already, the totals here by the author. And in this section down here, we're getting the max and minimum dates for that user. So if you select a user, you want to select the date range where they contributed and show that what they contributed within that period. And then the last portion, I would have had you use SD experimental fragment, which we already covered earlier. And in this case, we create a plot chart. So that way, when you plot the chart for that specific period, it doesn't rerun the entire app. It just reruns the plot itself and the data set for corresponding for that range. And that's a really neat implementation that I want to show you there for XC experimental. And we're just passing in, creating the plot chart here, and then data set, and then showing the chart here, and the data editor. So you can get to see how the data editor looks like and how you can edit that. And then finally, if main function, save it, run it, you get the app straight up. And so the next part would have been chatbot, but since you have the slides, you can go experiment, look through the code, hack around. If you run into any issues, you can always find us online on Streamlit as well. Just hit us up. We'll be glad to help you out in that process.
Yeah, thank you so much, everyone, for coming. Check out that part if you're interested. And we'll have a booth on the main expo floor, so definitely swing by, and we'll get you some Streamlit swag.
Yeah.
Thanks.
All right, awesome. Thank you all.